Hello guys, welcome back to another video. So today we actually solved the LCA of deepest leaves problems, but we did so through our own custom approach, right? What we did was that we kept track of the parents, something like this. So for 7 the parent is 2, for 4 the parent is also 2, and then what we did was, since the parent is the same, then this must be the obviously the lowest common ancestor, or you can say the closest common parent. And why am I talking about 7 and 4? Because in the very first step, the first thing which I did was identify what the deepest leaves are, right? So we kind of did it in a custom hybrid sort of an approach where we um, iteratively did most of these stuff, right? These were the 3 cases which we discussed. And if you want to, dive more deep into what this is, you can see the video which is previous to this one. In this particular video, what we are going to do is we are going to solve the same problem but using a recursive approach, right? So again, same problem, everything is the same, constraint same. The only difference is that rather than using a iterative approach, now we are going to solve this problem using a recursive approach, right? So let's see how that can work. Let's think about this. Let's think about this. Dekho. What we are interested in knowing is, first of all, what the deepest nodes are, right? That's the first thing which I need to identify. So recursion, you must have this experience that it always sort of, not always, but in most cases, it unwinds from the bottom. So from the bottom to the top, isn't it? So let's do something like this. Initially, I am standing at the root. What I do is I will make 2 recursive calls. Okay, first I will make the recursive call to left node and then towards the right node. Towards the left subtree first and then towards the right subtree. So just keep this thing in mind. Okay, I go towards this particular node, left, right, and then again I go towards 6, and then again I go to the left, but then what you will observe is that this is null, isn't it? Because there is no one to the left of 6, there is no node. So when I encounter this situation, you can obviously very well guess at this point that this is going to be the base case. Okay, this is going to be the base case. Now a very important question arises, that what am I going to return from this? Because base case returns something, right? Isn't it? In 100% of the cases, base case is something which returns something to the previous function call, to the previous whatever state you came from. So what does this what does it need to return? Let's say it just returns 0. Okay, for now let's say that it just returns 0, as in on the left side of 6 there is 0 depth. Okay, so having made the left recursive call and having explored the left subtree of 6, now I will make the right call. Okay, this is also null. So what is it going to return to 6? 0, because there is no, you see, I would have returned a number which was greater than 0 if there was a tree on the right hand side of 6, right? There is no tree, so that's why I returned 0. Such in other words, in simple words, what I'm saying is that on the left hand side and on the right hand side of 6, there is a subtree of depth 0, which means nothing at all. Okay, null. This is the condition. Even if there was one single node like this, the depth would have been 1 in that scenario, right? So a depth of 0 means that this is a leaf node, in very simple words. Alright, having made the left and right subcall, recursive call, what do I return from here? That's very important. You see, what do I return? I should return 1. Okay, but then do I need to return something else as well? Think about this. Do I need to return something else as well at this point? I should also return 6. Why? Because if for example 6 was the deepest tree, or 6 was the deepest leaf, then ultimately from here I would have had to return 6, right? So not only do I need to keep track of the depth, but I also need to keep track of the node. And what do we know from the question? We know from the question that when there is only a single node, it is the LCA of itself, isn't it? So whenever you come across any leaf node, what do you need to return? You need to return that it is the LCA node of itself. Okay, it is the LCA node of itself and it has a depth of 1. So similarly, what I'm going to do is I'm going to return null and null over here as well in both of these base cases scenarios as well. Okay. Now, having explored the left subtree of 5, now I will explore the right subtree of 5. So I make the right recursive call. When I reach this point, I make the left recursive call, and then again I go left, but then I realize that this is null. There is nothing. So what this is going to return to 7 is null comma 0. Let's say we sort of take a pair. Okay, we take a pair of tree node steric and an integer which is depth. So node comma depth, and then from over here as well, this is going to return null comma 0. Now think about this. I have 0 from here, 0 depth from here, 0 depth from here. So the only thing which I can, that lets me know that this is a leaf node. And then since this is a leaf node, what I can return from over here is 7 comma 1. Similarly, you know for a fact, even if I don't draw these two things, this is a leaf node. This is going to return what? 4 comma 1, as in the LCA of this node is 4, the LCA of this node is 7, and the depth of this subtree is 1. The depth of this subtree is also 1. You see, things would have been really different if I had a, let's say if I had a left child over here. Let's give it a value of, let's say, 70. Things would have been very different in that case. Why? Let me show you. So when I make the right recursive call from 2, I do not consider this 4 as a leaf node. Why? Because this is clearly not a leaf node, right? So after making the right recursive call from 2, I will make the left recursive call from 4. Okay, because that's what we are doing. First we make the left recursive call, then we make the right recursive call. Again, there's just a pattern, we are doing it repetitively again and again and again. So left recursive call returns null comma 0, right recursive call returns null comma 0. That lets me know that this is a, this is a leaf node. What this leaf node returns to 4 is 7 comma 1. So itself, it says to 4, it says to its parent, it communicates that I am the LCA of myself with this particular depth. Okay, so 4 receives 7 comma 1. At this point, you see, what is 4 going to do? 4, first of all, very important thing, it receives the 7 comma 1 from the left side, right? It's going to make the right recursive call, and since there is nothing over here, it's going to return null comma 0 from this point. See, this is very important. What happens when you have explored both the right and the left subtrees? What happens then? So you see, the depth is 1 over here, meaning that you had a node, one single node on the left hand side, but over here the depth is 0, meaning that you did not have anything. So what am I going to return from 4? What am I going to return from 4? First of all, I am going to compare the depths 1 and 0. The depth of the left subtree is clearly greater. Okay, so I'm going to take this 7 and I'm going to increment the depth by 1. 7 comma 2 is what I'm going to return to 2. You know why? Because ultimately, if I had 7 present, ultimately the LCA of the deepest leaf would have been 7. You see, it would have been 700%. And let's take this to the end and let's see why 7 comma 2, why 7 would be the LCA. So from on 2, from the left hand side I receive 7 comma 1, from the right hand side or let's 7 is already present in the tree, right? Sorry, this is 70, this is not 7, I'm sorry, 70. So from the left hand side I receive 70 comma 2, as in 70 is the node and 2 is the depth, and from the right hand from the left hand side I receive this, from the right hand side I receive this. Again I compared the depths, the depth of this one is clearly greater, right? It's clearly greater, so I choose this particular value out of these two, out of this one and out of this two, I choose 70 and I increment its depth by 1, meaning that the deepest, the deepest leaf had the lowest common ancestor as 7 and the depth is 3. At this point, it should be clear to you why am I keeping track of both the depth and the node. You see, both are important. The value is also important. The values are unique, by the way. No value kept, no value repeats itself. That's why I had to make sure that I take a unique value. So that's why you need to know that we are keeping track of the node as well of the depth, because on the basis of depth we are returning things to the above node. So you see, at this point I am getting 6 as the LCA node because I only had one over here, right? And from the right hand side, from 2 I'm getting 70 comma 3, which is greater, 1 or 3. 3 is clearly greater. So at this point, what am I going to return? The greater depth one, right? So first of all, I'm going to write 70 over here and then increment the depth by 1. You see, and at this point, pause the video and do the dry run for the right subtree by yourself. You see, we made the left recursive call from 3. It is done. Now what do? We make the right recursive call. Okay, we reach 1. But after reaching 1, we make the left recursive call. Again, left recursive call returns null comma 0. Right recursive call returns null comma 0. Null comma 0, null comma 0, it lets me know that this is a leaf node. So I return from over here 0 comma 1, meaning that the node is 0 and the depth is 1. Similarly, having done the left subcall, left recursive call, I go over here and this is a leaf node, so ultimately this is going to return 8 comma 1. You see, we discussed about two possible cases. What are those two possible cases? Those two possible cases are these. So you could have a scenario something like this, where the depth which you are receiving from the right subtree is greater than as compared to the left subtree. The depth which you will receive from over here is 2 and from over here is 1, right? You could also have this scenario that the depth you receive from the right subtree is greater as compared to the left. But then there could also be a scenario where the depth is the same. What do you do in that particular scenario? In that, for example, this scenario. In that particular scenario, this node receives 1 from the left side, 1 from the right side. In that particular scenario, you know what you do? You return this particular node because this is the LCA of 0 and 8 both. You get it? And this is, this is something which we know. Neither 0 is the LCA of itself, neither 8 is the LCA of itself, but 1 is the LCA of both of them. So I will return 1 from here. Okay, with the depth what? With the depth of 1 plus 1, 2. So node is 1 and depth is 2. So you see, I am receiving 70 comma 4 from the left subtree, overall left subtree. So I can say that the left subtree has the lowest common ancestor of the deepest leaf as 70 with the depth 4, and from the right subtree I have the lowest common ancestor of the deepest leaf as 1 with the depth of 2. Which depth is greater? Obviously this one. So ultimately from the root, what am I going to return? From the root I am going to return 70 with a depth of 5, and this is something which I capture in the main function. Okay, after having captured in the main function, I return this thing as my answer. As simple as that. So have a look at this process again. Okay, if it's not clear, have a look at this process again, because this is what you need to understand. Okay, this is literally what you need to understand. If you understand this, you can write any recursive code in the world. Okay, so let's have a look at how we are going to write the solution. You see, what did we say? We said that if you stumble upon something which is null, what are you going to return from there? You're going to return a null pointer, comma 0, 0 depth. That is exactly what we are doing over here as well. Then you make the left recursive call followed by the right recursive call. Isn't it what we were doing? Right. After having made both of the recursive calls, what do? Do you remember? You compare the depths. Always remember this. Not remember actually, but try to understand this. Don't memorize this. Try to understand why we are comparing the depths. You see, why did I carry forward the 7 comma 1 over here, 70 comma 1 over here, and not the null comma 0? Because this had greater depth. And similarly, the same thing over here. I had 1 comma 2 and I had 70 comma 4. But why did I return 70 comma 4 after incrementing? Obviously, why did I return 70 and not 1? Because it had greater depth. If it has greater depth, then it means that it's probably coming from the deepest leaf. Okay, makes sense. So that's basically the game. That is exactly what we are going to do over here as well. So I compare the depths left dot second and right dot second. What does left dot second and right dot second mean? This is the left recursive call. Left dot, देखो, let me make you understand. This is dot first, this is dot second. Okay, and this call was for the left pair. This call is for the right pair. This is right dot first and right dot second. Okay, so right dot second means the depth of the right subtree. Left dot second means the depth of the left subtree. All right, I compare both of them. You see, if left dot second is greater than right dot second, so what do I need to return? The left node value, the left node actually, because ultimately we'll be returning a node along with its depth plus 1. Similarly, if the if the right one, if right dot second was greater than left dot second, what I would have done in that case is I would have written right dot first and incremented its depth by 1. And then remember what happens when you have the same depth. What happens when you have the same depth? Example, over here, I had 0 comma 1 over here and I had 8 comma 1 over here. In that case, what you do is you return the root itself. This particular node itself, you return it and increment the depth by 1, since the depth is same overall, so you can take any one of them. So if if the depth is same, neither this condition is going to be met, neither this condition is going to be met, but this condition is going to be met. So you return the root and then you do left dot second plus 1, and since the depth is same, you could very well do right dot second plus 1 as well. So if I submit this code, let's see if it passes all the test cases. Right, it does. So if anything from this picture is not clear, do ask me in the comments and I'll make sure to inshallah reply to you. Take care.